Chitra, are you there? Oh, Chitra? I think he has gone somewhere. Yeah. So I think he is asking a question. Um, I don't think we covered defocus microscopy. Are you talking about the depth from defocus technique? All right. Yeah. Yeah. So what is your question? Okay, it's possible to share some tutorial. Okay, we will make a note of this. Okay, I will send you a tutorial, but that might take a few days. Okay, but we cannot give you the code because the code is patented. Okay, so but we can explain to you how the algorithm actually works. All right. Okay, but there will be certain things which we cannot share, like the code part and the actual implementation logic, because those are confidential or proprietary. But we can tell you the basic, the basic fact. Okay, I am also going to send you the paper, which you can read and see if you. That is also very detailed. There are a couple of papers which will provide you more details on this defocus technique. Okay. And additionally, we will also post a tutorial. Maybe for everyone, we can have a short tutorial. But I think the lecture materials are like tutorial. But anyway, but we will provide some additional materials, maybe a few more slides and those two papers in the forum. Okay, so the TAs will actually do that. All right. Thank you, Chitra. Yes, Mahesh, you have a question? Mahesh Malage, do you have a question?
Yes. Good morning, sir. Hello.
Please state your question.
Yes, sir.
Yeah, state your question.
Yeah, just I just joined, sir. Just 2 minutes.
Okay.
Hello.
Yes, Mahesh, you can ask your question.
Okay, so actually, I'm working on that this one spray cooling on cylindrical surfaces. So
Okay.
I want to know if I want to measure the droplet distribution.
All right. Ah,
So is there any visual techniques to measure like how like this we have studied in course like various like the shadowgraphy and this technology are there, no? So
no,
I
no.
want to
Where do
ask
you want to measure? Okay, where do you want to measure? In the spray phase or after it impinges the surface?
after it impinges on the cylindrical surfaces.
Okay, okay. So it will be standard shadowgraphy. I think that is what
Okay.
we use. Okay. And
Okay.
also the depth from defocus if you want to, capture the droplet size distribution. Both can be equally effective. But I think you should try shadowgraphy first. That is the easiest technique. And that should give you a reasonable idea of the droplet sizes as well as of the velocity. You can also get velocity. Okay. Uh,
Okay.
so you are done.
One more. Yes,
Yeah.
sir.
Go
Yeah,
on.
yeah.
Go on.
One more. Actually, I have like a bank of tubes are there. So actually, the physics is that droplets, some droplets are getting like say bouncing, and some intermittent effect is there. Can we measure that also?
Yes, it depends on the what is the framing rate of your camera. Okay.
Okay, okay,
If you have high speed imaging, you can do. Okay. If you have
okay,
low speed imaging, then you cannot do that. Okay. So
okay,
if you want to capture intermittent image, the full cycle. Okay.
okay,
So you have to. I mean, I have to see the exact setup to suggest.
okay. Setup. Okay, sir.
No, I mean, if you feel comfortable, you can set up picture or a schematic with us. We should be able to advise you on the diagnostic technique, but you have to be comfortable because I don't know what kind of
No,
you're doing and whether it is confidential or not. All right.
no. Okay, sir. I will join with my laptop. Actually, I'm on mobile. It's not in mobile. I will just
That's
join.
okay. You don't have
With
to send it now. No, no, you don't have to send it now. You
okay,
send fine, we will respond. But on prima facie, we can tell that you need shadowgraphy with a reasonably high speed camera. Okay.
okay,
If
okay,
you require more information, you send the schematic and your experimental conditions and the operations,
okay.
and we will be able to give you some suggestions. All right.
Yes, sir. Sure, sir. Thank you.
Okay. I think we have another one, Rupali. I think Rupali is there. Yes, Aditya Thakur. Aditya Thakur, do you have a question?
Hello, sir.
Yes.
Uh, so I want to ask regarding this exam. Actually, with this, whether it will be online or pen paper exam for
It will,
this course,
it will be online.
it will be online. Okay.
MCQ type.
Okay. MCQ type.
Yes.
It will comprises of both numerical, matlab, as well as theoretical questions, right?
Yes. Similar types that you get in the assignments.
Okay. Okay.
Oh,
So during this measurement techniques, say shadowgraphy or say shadowgraphy, how we measure like uncertainty, like how we define for that case?
uncertainty of what? The shadow.
Uh, yeah.
So there are varieties of errors. Okay. For
Yes.
example, your optics, your geometric optics will give rise to a certain error. Okay.
Yeah.
And the camera will have a certain amount of error. Okay. So these are errors, these are systemic errors that you can actually find out before even you start doing an experiment. And then, of course, there are dynamic errors that can happen. For example, in shadowgraphy, your droplet velocity might lead to, what we call your images become blurry. So it's a blurring of this, for example. Okay.
Right.
And there could be your object could be a little bit out of the depth of field. So that could also lead to an error. Okay, so some of these errors will be dynamic, some of these errors will be systemic. So some of the errors you know beforehand so that you calibrate and you account for those errors when you are actually processing the images. But some of the will be kind of dynamic. For that, you need to follow varieties of protocols. You need to have an idea of the velocity, and then you need to do multiple experiments. You need to play with your, for example, your shutter timing, your image acquisition time, okay, your lighting systems, and all those things. Okay. So all these things can be done. So there is no one clear-cut answer that what will be the error. That's why each experiment will have its little bit of its own error. And you also need to take care of the consistency of your measurements as well. Okay.
Okay.
So all this, and then you have to consider certain, certain theoretical errors that can actually crop in. For example, the Nyquist criteria, as an example,
Mhm.
right? So you have to know all this stuff beforehand. Okay, so that is all part of the experiment. When you become an experimentalist, you learn all these things on the go.
Okay. Like I want to ask, like how we quantify, like this is like if image is getting blurring, how we like quantify in terms of like say equation, like say delta T but is if temperature is there, like
Blurring is bad. So blurring is bad, as you know. So you have to, for example, if the object is flying at a certain rate, and if your camera acquisition or your shutter
Mm.
time is say y, okay, so you
Okay.
have to calculate, for example, if the droplet has a velocity v, so in x
Mhm.
time, how much distance it will cover. Okay, so
Okay.
and now you are capturing the image over a time y because you are
Mhm.
basically collecting light. So you know the extent by which the image will be extended. Okay,
Yeah,
or
yeah.
the kind of blurring. Now, if you calculate and you find that that blurring extension is about say 0.5% or 0.1% or 0.2%, whatever it is, okay, then that is what you report. That this is the
Yes.
extent of the blurring that I get in my image. I mean, this is one example. Now you see whether you can live with that kind of an error or not. Okay, sometimes
Mhm.
it's measurements, even 5%, 10% error is all right. Okay, but in some cases, you might require very accurate measurements. For that, you might need 0.1%. So it depends on your equipment, your need, and what kind of a measurement you are trying to perform. So blurring is just an example. There could be other types of things. Depth of field is also another problem. That also will lead to blurring, but that also you can calculate that when an object goes out of the depth of field, how much is the extent of blurring it will have. Okay, that is geometric optics. You can calculate. Okay, and then you can find out that if, for example, a droplet has got a velocity inside the, I mean, perpendicular to the plane of observation. Okay, then how much it will go out of focus in the time scale when you are actually acquiring the image. So that will give rise to another blurring, but in the perpendicular direction. So there can
Yes.
be all kinds of stuff that we. So this is how you quantify when you actually report your experimental data. You calculate all of these things in the background. Okay.
Okay, sir. Thank you, sir.
Yeah. Surekha D, do you have a question? Surekha, do you have a question? Yes, come in. Come in, come in. Oh. Hey, sure. Somebody asked.
Hello. Hello.
Hello. Hello.
Hello.
Yeah, who is asking the question?
Hello.
Yeah,
Sir, good morning, sir. I am Prakash.
you are
Uh,
who? You are who? What's your name?
Prakash Chandra Sahu from currently doing postdoc at IIT Kanpur. So
Okay.
I have some few query regarding the actually, sir, when we have changed the surface tension during the droplet dynamics, right? So what happens? The Weber number, Wenzel's number, and Bond number, the non-dimensional number will change.
Hmm.
But how to handle this for analyzing the droplet impact on the surface, like to analyze the spreading behavior?
How to maintain the properties? What is
How
your
to hand? Uh,
how to get the properties?
yes. Let's say if you change the surface tension experimentally, then
Uh,
three non-dimensional number like in denominator, that is Weber number, the surface tension is there.
uh,
Wenzel's number also surface tension force is there, and Bond number also surface tension force is there. But
uh.
for analyzing the spreading behavior, so how to interpret these three number? Like
Okay. So that's very okay. So you are asking a question which is not necessarily on measurements, but on the physics of
yes, sir.
picture. Okay.
Yes.
So what I foresee is that if you are going to change, say the surface tension, okay, what do you think is going to happen to the droplet? If the
Yes.
surface tension is low, okay, initially the droplet will spread. So that behavior will be a function, that initial behavior will be a function of only the inertia of the droplet. But after some time, when the droplet starts to recoil back, it will be a function of your surface tension. So look at the simple literature on the Weber number scaling of droplet spreading and recoil. That will give you the idea. So if you can measure that, okay, so obviously the surface tension where it is more, the droplet will recoil more, recoil faster. Okay. And it will, so how far the droplet spreads and how the droplet recoils, that should give you an idea that what is the dependence on Weber number. Now, Weber number is a function of, as you know, is a function uh, of your inertia and surface tension.
Initial surface tension.
Okay. So that will be a very crude idea immediately. Of course, it depends on your surface. It depends on a lot of other stuff. Okay, it depends on a lot of surface instabilities that develops along the way. But this is a very rough cut answer. All right.
Okay.
Anything else?
Sir, I have just add some one more thing. Sir,
Go
actually
ahead, go ahead.
doing in computationally,
Uh,
like in code or anything like in commercial software, what you have to do, you have to suppose for Weber number, like in braking force, you have to change the velocity, impact velocity, according to or like Wenzel's number, viscosity, and Bond number, that is you have to change the surface tension of the droplet. But in
uh,
experimentally, you have to compare these three, like in Weber number, Wenzel's number, to correlate all those things in terms of deformation factor, like how to manage these three parameter, non-dimensional parameter with respect to the surface tension force. like in Sigma?
Manage these parameters. I mean, these are, I don't understand your question because you're.
Actually, sir, in computationally, what exactly happens, the deformation, like when the droplet impact on the plane surface, the deformation factor, like maximum deformation, that you have to change, like in if you vary the parameter like impact velocity in terms of Weber number, non-dimensional number, and Wenzel's number, like the viscosity of fluid in terms of Wenzel's number, and the bond number, suppose you can say you can change the surface tension of force in terms of gravitational to surface tension force, that is in terms of bond number. But if you change these three parameters in like this, then you can determine the deformation factor in terms of three non-dimensional number, right? But if
Okay.
you do some experimental work like this type of, then how to manage this? Like in if you change
Oh, you are
once,
talking about the fluids, what kind
yes,
of
yes.
fluids? So that would
If
be difficult initially, but you can change the fluid. You can use polymeric fluid, for example. You can also use, you can add, for example, glycerol to water. Okay, you can change the height from which the droplet is falling. You can do varieties of ways. Okay.
okay,
So you have to first, but of course, numerically, you can cover a lot of space. Experimentally, because these are real fluids, so you cannot have all the Weber number and everything covered. Okay, but so you have to choose a space. Okay, where,
okay,
where you can get the maximum variation in the parameters or whatever that is you that it is you are trying to do. Okay, so all right.
okay. Thank you.
Okay, so next one, next person.
Madam, hello, hello, madam, first,
Yeah,
first,
yeah, go ahead and ask.
my online,
I cannot hear you.
madam,
Anybody else has any question? You can also post the question in the forum. Okay, and we should be able to get an answer, you know. Yes.
Sir, if there are no questions, we can wind up, sir.
Okay. Let's wind up then. All right.
Okay, thank you, sir.